Welcome. In this video, we are going to take a look at solving quadratics by factoring. So we're going to put together our factoring tools with our quadratics to find values that make our equation true. So to start with that, we're going to use something called the zero product property. So the zero product property just tells us that if we are multiplying two things, so if I have two things that are being multiplied together, then one of those things has to be zero. The only way to multiply and get zero is if one of your factors is zero. So what we're going to be looking for today, solutions, zeros, x-intercept roots, these are all things that mean slightly different things, but all relate to the same things in our quadratic equations. So today we're going to be solving, so we're really finding solutions, but you might be asked to find roots as well. If we're looking at this graphically, it looks like our x-intercepts. So if I am going to solve this quadratic equation, you can see this equation is a little different than the ones that we looked at with just factoring because it's equal to zero. So really, really important when we're going to solve quadratic equations by factoring, we first need to be equal to zero because what we're going to end up using is this zero product property. So if I factor this, I'm looking for what things multiply to be -6 and add to be -1 because I know I have an x and an x. We multiply to be a negative, so one's negative, one's positive, and they have to add to be -1, so that would be -3 and +2. So each of those factors could equal 0 to make the whole thing be 0. So if I set each of these factors equal to 0, then I have two much more simple equations to solve rather than this equation that we started with. Because now these two things are multiplying to be 0. So using that zero product property, I can set each one equal to 0. So I get x is 3 or x is -2. So if I take either of those things and plug it into our original equation, so if I put 3 squared minus 3 minus 6, I should get 0. And also if I put -2 squared minus -2 minus 6, I should also get 0. They're both zeros of that equation. They are both solutions to that quadratic equation. So same process we're going to use for things. We're going to get it into factored form. Once it's in factored form equal to 0, you can set each of the factors equal to 0 to solve. So this first example here, it's already in factored form, right? X times x minus 2, which means either x has to equal 0 or x minus 2 has to equal 0. So this one's already solved. This one pretty quick to solve, x equals 2. So we get these two solutions, x is 0, x is 2. Now let's plug those back in, make sure they work. 0 times, I don't even care what that is, 0 times something is 0. If I plug in 2, 2 times 2 minus 2, well, 2 minus 2 is 0, so we also get 0 there. That one was already factored for us. What happens if it's not? Well, we'll just use our factoring techniques. So here I have a quadratic, it's equal to 0. I have h squared, so I know I have h and h. Okay, we're multiplying to be positive, add to being negative, so they both have to be negative. I'm looking for how can I arrange, make my rectangle of 35 to get -12, some factors of 35 that add to be 12. And so let's see, that's 7 and 5. Once we're in that factored form, now these two things are multiplying to be 0, which means either h minus 7 is 0 or h minus 5 is 0. Solve those much easier equations. We get h is 7 or h is 5. Okay, always a good idea to check your equation, right, by plugging those back in. If I do 7 squared minus 12 times 7 plus 35, I should get 0. If I do the same thing with 5, I should also get 0. And if you don't, go back and check your work. Maybe you factored incorrectly or forgot to add or subtract or something like that. Okay, first step, factor. Okay, because it's equal to 0. So again, I know I have x, x. I'm multiplying to be positive, add to be negative, so they both have to be negative. Multiply to be 8, make a rectangle out of 8, and 2 and 4, add to be -6. Set those equal to 0. We get x minus 2 equals 0, x minus 4 equals 0, add 2, add 4. We get x equals 2 or 4. Okay, a few more here. Oh, not equal to 0. So first step, you have to get it equal to 0. So x squared plus 4x minus 21 equals 0. Again, a is 1, so I'm just going to go directly into my factors. I'm looking for what multiplies to be negative 21 adds to be 4, so one's positive, one's negative. The bigger one's going to be positive. Factors of 21, 1 in 21. 2 doesn't go into 21. 3 and 7. Oh, that works. So negative 3, positive 7. And then set both of your factors equal to 0 using that 0 product property. We get x is negative 7 or x is positive 3. Okay, next one here, get it equal to 0. It doesn't matter what side the 0 is on. I'm just going to add 2x squared to both sides. I like my a value to be positive anyway. Okay, I want to factor that. Oh, they're all divisible by 2. Since this is an equation, I don't even have to factor the 2 out. Since it's not a variable, I'm not going to lose any information if I just divide everything by 2. And we can do that because of the division property of equality. So we get x squared plus 10x plus 25. So now I'm looking for factors of 25 that add to be 10. And we're going to end up with 5 and 5. Oh, those are the same. So I'm going to get one solution here. If we remember back to our characteristics of our graph, that's because this is a perfect square trinomial, which means I'm only going to get that 1, 0. We're only going to touch the graph on the axis at negative 5 just at that one time. Our vertex is on the graph. Okay, last one of this type. Again, get it equal to 0. Oh, I can't divide by 2 because that's not going to give me nice numbers because 9x and 35 are not divisible by 2. So we're going to use our ACB, multiply, we get negative 70. I need factors of negative 70 that add to be negative 9. So 1 and negative 70 doesn't work. 2 and negative 35 doesn't work. 3 doesn't go into 70. 4 doesn't go into 70. 5 and 14. Oh, there we go. That's our factor pair. So we're going to rewrite this as 2x squared minus 14x plus 5x minus 35, and then use our grouping. Greatest common factor here is 2x. We're left with x minus 7. Greatest common factor here is 5. We're left with x minus 7. So my factors are 2x plus 5 and x minus 7. Don't forget this whole thing's equal to 0. So either 2x plus 5 is 0 or x minus 7 is 0. All right, and then we're just solving those. This one's a little more work. We'll get 2x equals negative 5, x equals negative 5 halves. And here we just have to add 7. We get negative 5 halves or 7 as our two solutions. Not a bad idea to go back and check that. I'm going back to my original equation up here and say if I take 2 times negative 5 halves squared minus 9 times negative 5 halves, I should get 35. Good, that one worked. And then if we do the same thing with, I don't know why I did it like that, that's okay. 7. Been easier just to type it all in. It's okay. I should get 35 as well. So it looks like both of them work. So we're good to go there. Okay. Last thing we're going to do is look at going the other direction. So we're going to complete a possible equation with the given solution. So we're going to use our zero product property that if I have x equals 3, that means that x minus 3 equals 0. So that could be one of my factors. And if x equals 7, that means that x plus 7 equals 0. So I could have an equation where 0 equals x plus 7 times x minus 3, and that would give me these two zeros that we have here. Okay, same thing here. I could add a half, add a half. I could say x plus a half, but that's not super nice. So let's just multiply it by 2. And I get 2x plus 1 as a factor. And here, x minus 2 will give me that 0 and just set it equal to 0. So just using that 0 product property in reverse. So that's all I have for you today. Thanks so much for watching.